90 read, over. Roger, loud and clear on the high gain. Listen, Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
Welcome to this edition of NASA Images. I'm Lynn Bondurant. During this show, we're focusing on historic NASA documentary footage showing how satellites serve us. The short films we're about to see are aeronautics and space reports, and we'll begin with a portion of one released in 1965.
There were two TIROS weather satellites placed in orbit, TIROS 9 and TIROS 10. Between them, they spotted 5 hurricanes and 14 typhoons. Their television eyes transmitted thousands of photographs of the entire Earth to aid weather forecasters. Early Bird 1, the world's first commercial communications satellite, was launched by NASA for the Communications Satellite Corporation. Early Bird provides telephone, telegraph, high-speed data, and television between Europe and the United States. One of the 14 scientific satellites launched was an orbiting solar observatory, OSO-2. OSO's instruments provided information on the seething hot gases surrounding the sun and how its tremendous energy controls events on Earth and other planets.
Another filmed report released 2 years later in 1967 tells how communication satellites quickly linked up the world.
Okay, we're going straight up.
10 seconds. We're going to go to our slide.
Ready till up. 5, 4, 3, 2, 1. Take it. On.
Because of the following special one-hour broadcast, programs previously scheduled at this time will not be seen.
30 seconds on it. Stand by to wipe to the bird and take it live early bird. Wipe. And you're in there. Mexico is on the line. Mexico is feeding the bird. Light X1. Wipe now on Mexico.
This event, television beamed via satellite, is now commonplace. To make it possible, an experimental program was initiated in 1958 to develop the technology, the capability for communication satellite systems. The advantage of satellite communications is height. Microwave transmitted in a straight line carries telephone, teletype, and TV. But a hill in the path of a microwave tower can block the signal, and the system stopped at the ocean's edge until we had communication satellites. ECHO, NASA's first experimental system, was a passive communication satellite. Passive because it served as a giant mirror, reflecting signals transmitted by one ground station to the receiver of another. Then Telstar and investigations of active communication satellites, called active because they have the ability to receive, amplify, and retransmit signals to distant locations. It was AT&T's Telstar that provided the first live intercontinental television transmission in 1962.
Kiki, la chansonnette après l'épée.
Because Telstar was in sight of ground stations for short periods of time, transmissions were intermittent. Another medium-altitude satellite was NASA's Relay 1 and 2. Thousands of tests and experiments were conducted over Relay, many involving transatlantic and trans-Pacific television transmissions. Next, a high-altitude satellite orbiting at the same relative speed as Earth, appearing to hover at one point at all times. NASA's experimental SYNCOM satellites were the first to be placed in such synchronous orbits. It was via SYNCOM 3 that live television coverage of the Tokyo Olympic Games was accomplished. From experimental to operational, the Communications Satellite Corporation adapted the SYNCOM design concept to the world's first commercial communications satellite, Early Bird 1. With Early Bird and later operational communication satellites, long-distance telephone, telegraph, and television transmissions have become a common occurrence. Here, heart surgery seen thousands of miles away as it was performed. To test even newer communications concepts, NASA is placing in orbit a series of applications technology satellites. They will be used to try out new systems for improving aircraft communication, color television, and many other advanced experiments. Whether spanning continents or oceans, experimental and operational communication satellites are playing an increasingly vital role.
Not only are satellites used to help the world communicate better, but they are used to peer into the universe, as this 1971 film shows.
Recently, a small astronomy satellite nicknamed SAS was launched from a platform off Kenya, South Africa. Managing the project for NASA's Goddard Space Flight Center in Maryland, Mrs. Marjorie Townsend. Here she describes the SAS mission.
The mission of the small astronomy satellite is to map the celestial sphere for X-ray sources. These are stars that radiate X-rays, and it's only since the advent of the space age that we even knew that there were stars in the sky that did send out X-rays, because X-rays don't penetrate the atmosphere. The astrophysicists hope that they will help to learn the origin of the universe from the data that they get back. The best launch site from which to launch high-energy astronomy experiments is near the equator at the San Marco launch site, owned and operated by the Italian government. This particular launch site is a very large barge elevated on several legs above the surface of the ocean, 3 miles east of the coast of Kenya in the Indian Ocean. SAS-1 weighs about 318 pounds and is orbiting the Earth every hour and a half, sending back large quantities of data.
We asked Mrs. Townsend how they ensure the spacecraft does what it's supposed to once in space.
A very great deal of effort and testing goes into building a successful spacecraft. For example, every transistor and integrated circuit is tested with an X-ray machine to see if there's anything inside that could cause a problem later on. Only tested components are used in the fabrication of circuit cards that eventually go into the spacecraft. The interconnecting harness is built with very great care and tested with extreme care, as is each circuit card, before they're all put together into the final spacecraft configuration. Then the total spacecraft is checked electrically for many, many hours to make sure that it's performing perfectly.
The small astronomy satellite, a little spacecraft doing a big job.
Another job Earth-orbiting satellites perform is Earth observation. Satellites can look at Earth below to find natural resources and can do many other important jobs too. This 1972 pre-launch film shows us such a satellite.
It's called the Earth Resources Technology Satellite. Weighing nearly a ton, the butterfly-shaped craft is 10 feet tall by 11 feet wide. This is the business end of the ERTS satellite. Housed here are the cameras and sensors that will always be pointed earthward, seeing and electronically touching the Earth. What can the ERTS see and sense from its vantage point in space? These are some of the things experimenters hope to study. It can detect water pollution trends and monitor pollutant concentrations in our air. By showing rainfall and snow levels, allow quicker prediction of potential floods. Monitor crop conditions. Provide timber inventories. Spot land use patterns. Locate underwater features in our oceans that are hazardous to navigation. Catalog surface rocks and mineral formation. Chart changes in ocean currents. And generally improve the mapping of Earth. The Earth Resources Technology Satellite will soon be launched by NASA into a 564-mile-high orbit. Circling the world 14 times daily, the Earth's cameras and sensors will methodically record overlapping images of large sections of the globe. Earth Resources Technology Satellite, a revolutionary tool that holds great promise for continually charting our planet and its resources.
Now let's see a post-launch film clip from 1975 which shows results from the LANDSAT Earth Resources satellite.
Color infrared photography was developed as a camouflage detection film during the Second World War. Now, the film is designed to record the reflected energy as red, and this is why on color infrared film you'll see that vegetation, trees or grasses and so on show up as red.
And simply insert it in these 4 areas here on this slide.
Gary North is chief of the Earth Resources Observation System at NASA's Space Technology Laboratories near New Orleans. He actually works for the Department of Interior. Several other federal and state agencies make use of the big NASA facility where moon rocket engines were tested during Project Apollo. Gary North spends a lot of his time showing city planners, conservationists, engineers, and farmers how to read and acquire LANDSAT satellite pictures, pictures that could usefully serve their individual needs.
We find, it's almost an old cliche, but to say that most of the people don't know what's happening. They're not familiar with the fact that the Department of Interior has a space program, or that NASA has designed an Earth Resources satellite which helps man inventory resources and look at pollution and so on. Usually they've thought of Apollo launches or the actual main theme of the Apollo program to land and safely return man from the moon. We've all heard, what are the applications beyond this type of thing? And the remote sensing space business is one of the biggest ones we feel.
North described information that could be helpful in several areas.
The use of the remotely sensed data for geologic applications is one of the most promising at the present time. Being able to detect new geologic structure, faults, lineaments, these types of things hold a great key to potential new deposits of minerals and petroleum and so on. Geographic applications usually take the form of land use analysis. This is land use mapping and planning, or any basic natural resource inventory assessment program. And we find that with the satellite data that you can pretty well map such categories as agriculture, forestry, water, urban areas, in the field of snow monitoring, where the snow line is. And therefore, as it melts during the spring, maybe we can have a better idea of the amount of water that enters the ground and surface water systems. And just monitoring the surface extent of lakes and ponds, or an area like in South Florida, where water is very important to the wildlife, the Everglades National Park, and of course the human systems, Miami and so on, they must all draw off this type of thing, and we can watch this with a repetitive coverage.
The Earth satellite data comes in 4 black and
From mapping to monitoring rangelands and grasslands, 2 LANDSATs 570 miles out in space continuously survey our natural resources and return thousands of useful images that can be made quickly available from computer storage to anyone who needs them.
Any of these scenes that you think might be of use to you.
In the field of communications, NASA over the years has developed experimental communication satellites which were used to advance the state of the art. This pre-launch 1974 film describes one of those satellites.
It's called ATS-F.
Well, ATS stands for Applications Technology Satellite.
Dr. Werner von Braun is Vice President for Engineering and Development, Fairchild Industries, builder of the soon-to-be-launched ATS-F spacecraft. Through master ground stations, ATS will broadcast television programs to small, inexpensive antenna receivers.
In other words, for the first time here, a satellite has enough power and enough beaming capability installed that the signal received on the ground is strong enough for reception essentially by a normal television receiver. As a result, we can equip thousands of remote locations with receiver sets that can get the benefit of direct television.
The most dominant part of ATS is its 30-foot antenna that beams signals to the ground. It's shown here unfolding as it will in space. From its 23,000-mile-high orbit, ATS can travel around the Earth once every 24 hours. Since the Earth rotates at the same speed, the satellite appears stationary. During its first year of operation, it will be put to good use over the United States. One of its major jobs will be to provide health services to remote regions.
Imagine a nurse in a remote settlement in Alaska is trying to give birth to a baby and runs into a medical complication. Then she can talk back through the satellite, using the satellite as a relay to get the advice and support from a medical doctor, say in the contiguous states or even from Anchorage. And he, in turn, can provide pictorial material as well as voice assistance to the nurse while she is delivering the baby, on real time, in other words.
Besides the health services, educational programs ranging from career guidance to teacher training will be telecast to those who need it most.
It has been estimated that in the Rocky Mountain states alone there are about 3 million adult illiterates. In addition, there are, of course, the children who also sometimes have very marginal school opportunities. Now, as far as Alaska is concerned, there are about 300,000 people in Alaska, and 50,000 of these people are estimated to live in settlements that have no permanent road access. And of course, during the winter months, and winter is about 8 months in Alaska out of a year, they are not accessible at all because of ice and snow and darkness, so they are completely excommunicado. And with this satellite system, effective school service could be rendered to these settlements in Alaska as well.
During the second year of operation, some 5,000 villages in India will receive telecasts from ATS.
This example with India, where 70% of a population of 570 million people will benefit from communication satellites by having at last some education available to themselves, is a classical example how a program that allegedly was the sort of a thing only the super rich can afford is now directly benefiting the poorest of the poor.
Health and educational television transmissions, navigation and air traffic control, weather research. These are but a few of many experiments planned for the new Applications Technology satellite.
The next film, made in 1975, shows how the Applications Technology satellite was used as a teaching aid.
These are my Rocky Mountains, I'll live here forever. My soul belongs here like the flowers of spring.
The Rocky Mountains, one-third the landmass of the United States, yet inhabited by only 4% of the nation's people. Thousands of small communities, inaccessible by ordinary means of communication, exist in relative isolation. Now, with the help of NASA's Application Technology satellites, a unique educational service is being offered to many of these remote locations.
Good morning, welcome to Time In. I'm Gene Giddings.
I'm Karen Beard.
Today we'd like to talk with Blanding, Utah and Busby, Montana, if we can.
To test the effectiveness of the system, junior high school students in 56 rural schools scattered over 8 states, including this one in Blanding, Utah, receive educational television programs daily. The programs, dealing with decision-making and career education, are transmitted via satellite from the Federation of Rocky Mountain States Television Production Center in Denver. Using simple, inexpensive antennas, the schools receive color television, and at 3 of the sites in each state, the students can also talk to their TV teachers in Denver. It's called Interaction.
Today's Tuesday, and as you know, that means that today's program talked about decision-making again. It talked a little bit about investigating your alternatives, gathering information about them, checking out their reliability and their probability.
So let's get right on. And again, we hear from Blanding this morning with any questions or comments you might have.
Hey, Jim, did you have a question?
Blanding with it.
NCC, this is BA71. Why are the 3 decision-making processes so important?
The question from Blanding is why is the decision-making process so important? Helen, Al?
Many people make decisions throughout their lifetime that they don't look at all the possible options that they have. And in fact, many decisions are made without having all the information.
We asked some of the students at San Juan Junior High School in Blanding how they feel they are benefiting from the satellite-transmitted TV.
Well, like if I want to do a certain job, well, how's it going to do? You can't learn stuff like that on TV. You can learn it here on a satellite program.
Oh, I learned a lot of things. How much education I need to get a certain job and all that stuff.
Oh, about how to make decisions in your careers and what kind of interests and abilities you need in certain careers.
How long will I get you out of going to another class?
Another major part of the satellite television transmissions is a course offered every 2 weeks for teachers not directly involved in the career education programming. As with the student interaction, so too the teachers can talk directly to the experts in Denver.
Utah, BA71, will you come in, please?
This is Blanding. We had a question concerning the financing or the funds that were, the way that you went about raising the funds for this fair. Over.
How did you go about the process of raising funds for this fair?
The first year that we did it, we did seek initial funding, and we went to the Junior League and the Chamber of Commerce and the State Departments of Education for that funding.
Education via satellite, extending communications into remote locations through the nation's first widespread trial of educational space technology.
Weather satellites, of course, have been very important servants for people across the world. Our next short clip from 1975 commemorates the 15th anniversary of weather satellites launched by NASA.
Kansas City, yes, that's the facility. I want to get the pretty good pictures on you.
We've come a long way in weather forecasting since the early balloon launching days, thanks mainly to weather satellites. Just 15 years ago this month, NASA launched the first TIROS weather satellite from Cape Canaveral. The views of Earth were pretty rudimentary compared to today's high-quality pictures, but they proved that routine global weather observation by satellite was possible. With each succeeding one, these weather sentinels have become more and more sophisticated. Here, the synchronous meteorological satellite. 2 are already in orbit, with a 3rd scheduled for launch this fall. Besides transmitting cloud cover pictures every 30 minutes, day and night, SMS can receive and send environmental information from thousands of manned and unmanned data collection platforms, located at sea, in rivers, lakes, and on land. The synchronous meteorological satellite pictures are made into film loops daily at the World Weather Center near Washington, D.C., to show cloud movement over oceans and land masses. Meteorologists are hopeful that this kind of information will give them clues to the weather conditions that, for instance, cause tornadoes and other fast-moving weather systems. Weather satellites. Over the past 15 years, they have returned more than 2 million pictures, provided advance warnings, and allowed no major storm anywhere on the globe to go undetected.
Our next clip from 1977 is about an astronomy satellite which was about to be launched.
Since the beginning, man has been intrigued by the stars. Stars spend most of their lives quietly burning away their nuclear fuels as if they were giant reactors. They are much more efficient at producing energy than is our primitive burning of fuels on Earth today. The sun is a small star, yet 1 second of its output is equal to all the energy ever consumed on Earth. Great potential benefits may come from studying and understanding the stars, how they produce energy, and then how they transmit it over millions of miles of empty space, losing little, if any, of its intensity along the way. All astronomy was done by human eyes and telescopes before space exploration with men and satellites allowed scientists to lift their instruments above the Earth's distorting atmosphere. High energy streaming out from the stars is hidden by this atmosphere. This is HEAO, short for High Energy Astronomy Observatory. It is the first of 3 such star watchers being readied by TRW for launch between now and 1979. Weighing nearly 3 tons, HEAO is made up of 2 parts, an experiments module and a spacecraft module. Once in space, this first high-energy astronomy observatory will rotate slowly so that over a 6-month period of time, it will scan the entire cosmos, mapping everything it observes: pulsars, quasars, supernova, and black holes. HEAO, a new space observatory to help us understand how extremely high energies are generated in space, perhaps unlocking secrets of the evolution of the universe, even showing new ways to generate power here on Earth.
HEAO-1 was successfully launched on August 12, 1977. The satellite was one of the heaviest launched up until then. Now let's see a very short 1977 clip showing animation about one of HEAO's first discoveries.
How stars produce the energy that makes them burn so bright, and then how they transmit this energy through millions of miles of space, losing very little intensity along the way, is of great interest to scientists. To study the stars, HEAO-1, High Energy Astronomy Observatory, was launched in August. Already, HEAO's instruments have found a gigantic star whose X-ray radiation increases violently over a period of time, then returns to normal. HEAO-1 will be joined in its task of mapping the sky for X-ray sources by 2 other observatories in the future.
That's all we have for this edition of NASA Images. But before we go, let me remind you that you are cordially invited to see displays here at the Visitor Center at the NASA Lewis Research Center. We are located near the Hopkins International Airport in Cleveland. Admission is free. From the Lewis Research Center, this is Lynn Bondurant. Goodbye.